in this module we will discuss first what is complex numbers and complex plane, and polar representation of complex plane. Then we will solve problem type 1, finding real and imaginary part of complex function. Then we will discuss continuity of complex function, and type 2 problem is check a function is continuous or not. So there are two types of problem. One is finding real and imaginary part of a complex function, and second type of problem is check whether the function is complex function is continuous or not. So first I will define what is a complex number and all. Okay, so we have a complex number. Okay, so a complex number is of the form z equal to x plus iy, where x is real part of complex number and y is imaginary part of complex number. So the coefficient of I is imaginary part, and coefficient of this part is real part. So this number is called a complex number. Now we can represent a complex function number in two ways. One is the Cartesian way, x plus iy, and second is in polar form, that is r equal to e power I theta. So how to represent a number, complex number in polar form? So I will draw the complex plane. So this is a complex plane. This axis is x-axis is real axis, x-axis, and this axis is y-axis is imaginary axis. We will call imaginary axis. So in imaginary numbers we will represent in imaginary axis, and real numbers we will represent in real. So z equal to x plus iy, this can be written as or represents. So x is a real number. So somewhere here x. So this distance is 0 to x. This distance is x. And I am representing y somewhere here. Y is an imaginary number. So this is this distance is y. So this we will represent it as xy. The point xy is x plus y. So this is the distance from 0 to xy. Now what we will do is, we draw this, we will get a right triangle. That is right triangle, and okay, this distance is y, right? Now what we can do, this is xy, that is x z equal to x plus iy. Now this angle is theta. Then we know that if this is a right triangle, then we know that what is cos theta? Cos theta is equal to adjacent side by hypotenuse. Hypotenuse. So this is equal to adjacent length is x divided by, what is hypotenuse? This is a right triangle. Then we know that by Pythagoras theorem, hypotenuse square, this hypotenuse square equal to base square plus altitude square. So x square plus y square. So what is hypotenuse? This is root of x square plus y square, and we represent that by r. So this length is r equal to root of x square plus y square, or this is equal to mod z. That means distance of z from 0. So this is r. Then we represent x equal to r cos theta. Similarly, what is sin theta? Sin theta is equal to opposite side by hypotenuse. That is, opposite side is this. Opposite side is y by hypotenuse r. This implies y equal to r sin theta. So now we can write z equal to x plus iy is equal to x equal to r cos theta plus I y equal to r sin theta. This is equal to r into cos theta plus I sin theta, which is equal to r into e power I theta. So we know that e power I theta is equal to cos theta plus I sin theta. This is Euler's identity. You might have studied. So we can represent complex number in two ways. One is x plus iy and other one is r e power I theta. So this is very important. Now the next section we will discuss. Okay, so now similarly, if you take any function, any complex function, so complex function, what is complex function? The complex function is a function of the form w equal to f of z. So this is a function f from some set s to c, where s is a subset of complex number. So this is a function defined from a complex subset to complex numbers. So some any point in here we have corresponding unique image. Okay. So similarly, if you have a function f of z is this can be written as, any function can be written as real part plus imaginary part of the function. So u of xy, this is real part of the function, and v of xy we denote imaginary part of function. For example, if you have a function f of z is equal to, example, f of z is equal to z bar. What is z bar? Z bar is conjugate of z. So this is if z equal to x plus iy, then what is z bar? X minus iy. Then here what is real part? Real part is u of xy is equal to, so here real part is x. And what is imaginary part? Imaginary part v of xy is equal to, what is the coefficient of I? This y minus y. So we can extract real and imaginary part from a complex function. Now we can do these problems. Yesterday I have given these problems to solve, and we can do few problems. So in the first problem we have this is a KTU examination. ഇത് frequent ആയിട്ട് ask ചെയ്യുന്ന problem ആണ് finding real and imaginary part of a complex function. So for first problem, so for find real and imaginary part of a complex function. So the first problem is we have to find real and imaginary part of z equal to f of z equal to z plus 3z. The solution. So here we have f of z is equal to z square plus 3z and we denote z by x plus iy, and we know that f of z can be written as u of xy plus iv of xy. So this we want to find out this real part and imaginary. Now what we will do is we can write u, just writing u plus iv. This I denote by u and this. So f of z can be written as u plus iv. This is equal to z square plus 3z, which is equal to, what is z? X plus iy. So you can write x plus iy all square plus 3 into x plus iy. Now x plus iy all square is x square plus 2xyi plus, you know, a plus b all square. So iy all square plus 3x plus 3yi. Now this is equal to x square. Now what is this? Plus 2xyi plus yi all square. You know that I square is minus 1. So minus y square plus 3x plus 3y. Now I am taking real part, all real part together. So this is real part. There is no I. This is real part and this. So I am taking x square minus y square plus 3x plus I times, what are the imaginary part? 2xy, and here there is I, right? 3 plus 3y. Therefore, u plus iy is equal to x square minus y square plus 3x and 2xy plus 3y. Okay. Now, therefore, what is real part? Real part is u equal to x square minus y square plus 3x, and v equal to imaginary part is 2xy plus 3z. So we get real and imaginary part of a function. So this is very easy problem. Now I will do the third problem. Second one you can practice. Third is I will do the third problem. Find imaginary, real and imaginary part of 1 by z. F of z equal to 1 by z. So this is equal to 1 by z. You can write it as x plus I by. Now what we will do is I is in the denominator. So I am multiply with the conjugate. So x plus iy into x minus iy, numerator and denominator, by its conjugate. So this is equal to x minus iy divided by x plus iy into x minus iy is x square plus y square. So what this implies, you know that f of z you can written as u plus iv. This is equal to, what is this? You can write x by x plus x square plus y square plus I into minus y by x square plus y square, which implies, what is u? Real part. Real part is u equal to x by x square plus y square, and imaginary part v equal to minus y by x square plus y square. So you can do similarly, you can do these two problems, and one more important thing is, if you have I in denominator, you should multiply with the its conjugate z bar. Okay, conjugate x minus I. Now Now this is the second type of problem. Now you can do similarly, you can do these three problems. Okay, first type problem. Okay, now next is okay, next section is discuss the continuity of a complex function. So I will tell you what is continuous function. So complex function. Okay. So a complex function f of z is continuous at the point z naught if limit z tends to z naught, f of z must be equal to f of z naught. Limit z tends to z naught, f of z is equal to f of z naught. Now we will this type of problem they will ask is check whether f of z is continuous or not. So the thing is we will use a polar form to solve this. This is very easy method. So I will insert the problem. Okay. So this type of problem is very easy. So this question is I will so the first question is check whether the function f of z is continuous at origin by assuming f of 0 is equal to 0. So the question is f of z equal to mod z square into imaginary part at z not equal to 0. So we want to check continuity at the point z naught is equal to 0. So we know that we will use polar form. So we know that f of z is continuous at z equal to 0 if and only if limit z tends to 0 f of z is equal to 0. If it is equal to 0 then sorry f of z equal to f of 0 then the function is continuous. So here what is f of 0 is equal to 0. Now we will convert this z in polar form. We know that what is z equal to e power I theta. Now as z tends to 0, we can this implies r e power I theta tends to 0. So z tends to 0 means r e power I theta tends to 0, which implies r tends to 0. So we can change z tends to 0 into r tends to 0. So the function is continuous if limit r tends to 0 f of z is equal to 0. Now we will check what is given f of z. f of z is given as f of z is given as z mod z square imaginary part of 1 by z. Now we will convert it into polar form. So z is r e power I theta. Then what is mod z? Mod r e power I theta, which is equal to mod e power r e power I theta is just r. Okay, so and what is imaginary part of z? 1 by z. So this we want to calculate. So imaginary part of so z, we know that z equal to r e power I theta. Then what is 1 by z? 1 by r into 1 by e power I theta, which is equal to 1 by r into minus I e power I theta. E power I theta. So this is equal to 1 by r into cos theta minus I sin theta. So what is imaginary part of 1 by z? 1 by r minus 1 by r sin theta into sin theta. So this is the imaginary part. Now we will look at what is limit r tends to 0 f of z. This can be written as limit r tends to 0. What is f of z? Mod z square. Mod z square is mod z is r. So r square into imaginary part of 1 by z is minus 1 by r sin theta. So this you will get. You can take this is limit r tends to 0 r into minus sin theta. So the limit is in r. So sin theta is a constant. You can take outside. So minus sin theta into limit r tends to 0 r. So what is limit r tends to 0? This is equal to 0. Therefore, what you will get? Limit r tends to 0, f of z is equal to 0, which is equal to f of 0. So what we get? We got limit r tends to 0, f of z equal to f of 0. Therefore, the function is continuous. So how to check continuity? We have to check whether limit r tends to 0, f of z equal to 0 or not. So here it is 0, therefore continuous at z equal to 0. So if I get 5 minutes, I will do the second problem too. So this second problem, I will delete this. I will give an idea for doing second problem. So we have to check whether this function is continuous or not. So what we have to do? First, we will take z equal to e power I theta, r e power I theta. Now z square, we know that r square e power I theta whole square is I 2 theta, and this can be written as r square cos 2 theta plus I sin 2 theta. Okay. Now we have to check limit r tends to 0 f of z is equal to 0 or not. So this is limit r tends to 0. What is imaginary part of z square? Imaginary part of z square is equal to r square cos 2 theta. Sorry, imaginary part of z square is r square sin 2 theta. What is mod z square? Mod z is r, mod z square is r square. So now we will write this. So imaginary part of z square divided by mod z square. This is equal to limit r tends to 0. Imaginary part of z square is r square sin 2 theta divided by imagine mod z square r square. Now you can cancel out r and r, which is equal to limit r tends to 0 sin 2 theta. This is equal to, you can take sin 2 theta outside, sin 2 theta into limit r tends to 0, 1. Here there is no term, so limit r tends to 0 into 1. That will be equal to 1. So this is sin 2 theta, which is not equal to 0. So this is not equal to f of 0. So what we can say here, limit r tends to 0, f of z not equal to f of 0. Therefore, f of z is not continuous at z equal to 0. So this is not. Similarly, you can do this problem too. And so these